All right, so we're almost ready to start now. We're going just to upload, the data set by clicking this little folder here. And then right now it is connecting to runtime to enable file browsing. And in a second, we should be able to see the upload button. Here we go, to upload indeed the data set. And now we are on my desktop. That's where I put my machine learning dataset folder, but make sure to go wherever you saved it. And now inside, we're going to go to part 2 regression, and then decision tree regression, and then Python. And then there you go. You select your position salaries dataset and click open. And this will upload the dataset inside the notebook. And now we're ready to start. Let's just run these two cells here. The first one to import the libraries, and then the second one to import the dataset. All right, perfect. So now we have the dataset, and of course the matrix of features X containing only the position levels, and the dependent variable vector containing the salaries. All right, and here, quick reminder, this model that we're about to build, you will totally be able to implement it on your dataset, and you will only have two things to change, which are first, of course, the name of the dataset here. You will put the name of your dataset, and then in a matrix of features, well, maybe you will want to select all the columns. And here we just excluded the first column because this contained only the positions in strings, which are exactly the same as the levels in this column. So of course we didn't want to include it, but check your datasets, check if you want to include all the columns, and mostly check if you need to apply some of the tools of your data preprocessing toolkit, which are either, taking care of missing data or encoding categorical data, right? So you would need to check the variables and see if there are some categorical variables in strings. If the order matters, like, for example, the size of a cloth, well, you will apply label encoder. And if the order doesn't matter, like some countries or some states, well, you will apply column transformer with one hot encoder. All right, and then you don't have to apply feature scaling. You can totally split your dataset into the training set and a test set if you want to evaluate your model on new observations, but you don't have to apply feature scaling for decision tree regression and neither for random forest regression. Why is that? That's because, the predictions from a decision tree regression or random forest regression model are resulting from successive splits of the data, through the different nodes of your tree, and therefore there are not some equations like with the previous models, and that's why, of course, no feature scaling is needed to, split the different values of your feature into these different categories leading to different predictions. We can still do this with the original scale of your features, even if your features take different ranges of values. All right, so remember this, no feature scaling, and then check for the other tools, but just for your future datasets where you would like to apply decision tree regression. Okay, perfect. So we have everything. We have the dataset, and now we're ready to build the decision tree regression model on the whole dataset, right? This time we don't want to split it. We want to leverage the maximum data to understand the correlations in this small amount of information. So we will train it on the whole dataset. Then we will predict our final result, the salary of the position level number 6.5. And then at the end, we will visualize what the regression curve of the decision tree regression model looks like. All right, so let's do all this in the next 3 tutorials, starting with this step, training the decision tree regression model on the whole dataset. And until then, enjoy machine learning.